we discuss applications of Bernoulli's principle, and for that matter the Bernoulli's equation, which is P over rho plus half V square plus GH is equal to constant. And that way we try to explain certain physical phenomena that we observe every day and where the Bernoulli's principle is being applied. And the parameters, that we have density there in the Bernoulli's equation, we have pressure, we have velocity, and the height or the distance, that is that varies, or that can vary. So we see when one of the parameters vary, when one of the variable vary, how does it affect the motion and what kind of motion in turn takes place. And in process, we also see how a plane can fly, how does a perfume spray work, what is the Venturi effect, and why does a cricket ball swing or a baseball curve. So those people who are interested in cricket, they would be familiar with the word that such and such player has been a very good swing bowler, or somebody can be a swing bowler himself. And this is a term that is very well known in our country to the youngsters, and we hear it every day. Why does the ball swing? Why does it curve away? It leaves its path and takes a turn. We try to explain it during the process of this, and you will see that we may be giving multiple examples, and in that case there may be a bit of a repetition also, so please ignore when there is a repetition. It is inevitable at times, and it just happens in the flow of thoughts. One of the examples is, if the air or wind is blowing on an aerofoil, this wing corresponds to the wing of an aeroplane. And the terminology, in the engineer's terminology, it's known as aerofoil. You can see its shape, that it on one side it's a bit fat, and on the other side it thins out and it takes a curve. So as the wind moves in from left to right with a certain speed, let's say V, then it attacks this place, this body or aerofoil, at three places: at the center, on the top, at the bottom. And three different effects takes place. So along a streamline, as we know, the Bernoulli's equation have to be constant. Remember that. And from that we have all the equations, all the implication that takes place. P over rho plus half V square plus GH is equal to constant. You may observe that. So this has to remain constant. So what happens if there is a faster air on the top, as it says? The velocity will be higher, and therefore pressure reduces, because this quantity has to be constant. And therefore at this place, so there is a relation between the velocity and the pressure. If velocity is higher, it increases, the pressure decreases. And where the velocity or the air or the stream hits at the bottom, it bounces downwards and the wings goes upwards, because it provides a lift. There is a force and the action and reaction. So as a reaction, the air goes downwards, but it is pushing the aerofoil upwards, that we call as lift. So in this aerofoil, there is a lift that is being provided upwards by the air that hits on the ground. And on the top of it, you can see that the velocity is going faster, it increases, and so therefore there is a decrease in the pressure. So that the totality of the Bernoulli's equation remains constant. We are repeating here the same thing, that greater air speed on the top and the less air pressure will be there. And when the pressure is less, it sucks in more air. And so field of activates, a flow field takes place because of this, because of the pressure difference. And therefore, we have a lift which acts in the upward direction that pushes the plane or the aeroplane in the upward direction. And at the bottom, there is less airspeed and the pressure increases, again adding to the lift. So less pressure on the top, it pushes the thing downwards, and more pressure at the bottom, which pushes the thing upwards. And these forces together, they result in providing a lift to the aeroplane, for example, and providing it a lift. And you can see because of that, the aeroplane here is taking off. When it generates a certain speed, at that time, they have a sufficient speed where they can take off, and the pilot of the aeroplane, then he can take the lever up, and therefore the plane takes off. But first it has to develop a certain amount of speed so that there is enough thrust or lift that is available to the plane which can support its flight into the air. The forces that are acting while it's trying to take off or it is flying off is drag. Drag is the force that is acting in the opposite direction of the flight of our main object. So if the plane is taking off in the right direction, the drag is opposing that, and it's a force that is due to viscous effects. It takes place in the reverse direction. So frictional force is always in the opposite direction as compared to the direction of the flight or movement of the body. There is thrust. We discussed that thrust, because of the pressure, higher pressure at the bottom, it provides thrust upwards to the plane, and that thrust enables it to take off. So it helps in the lift that is required. And another force is a gravitational force. Gravitational force, of course, is always acting in the downward direction, in the direction where the center of gravity of Earth is. So these are the forces that are acting when the body is moving, and the resultant force should be good enough to support the flight of the flying body, whether it is airplane or any other body that is trying to move into the air. If we try to reverse the aerofoil, then in that case the same phenomena is reversed. That is, the velocity becomes faster at the bottom and the pressure reduces. And on the upward, the pressure is higher and the velocity is lower. So it's a inverse phenomena as compared to the aerofoil that we just discussed above.